Everyone. So as I was discussing about the time complexity and space complexity. So yeah, it is it. Whatever we are going to discuss there, and you have also seen the code and what the importance. So there is a lot of more importance when you will actually you will be writing the code. You will see the importance. So now after that, it's really very important to understand today's agenda. This was a prerequisite, like whatever you are going to learn, whenever you are going to learn, you have to understand about time and space complexity. So in today's class, after discussing the content, obviously I will discuss about the roadmap at first, that what we are going to learn and how we are going to learn. After discussing the content, I will jump into two very important programming technique or programming paradigms, I would say. So the first paradigm is sliding window technique, and the second paradigm is or the algorithm is dynamic programming. Sliding window is a very famous technique for solving questions of arrays, and we can solve like the problems like that can be solved in quadratic, linear, or in quadratic, or let's say in cube time. We can solve this question in linear time. So that's why sliding window is very easy, and I will discuss the sliding window technique from basic, that how to build your intuition and how to write the naive code as well as how to write the efficient approach. I will show you both the things, the optimized approach. And also for dynamic programming, this is like any programmer's dream to understand dynamic programming. So in today's class, obviously I will be discussing about dynamic programming, that why dynamic programming is important, how we can write dynamic programming things, and obviously there are multiple things like memoization and tabulation. I guess you have heard about these terms, memoization and tabulation. How to write those code very easy, and why recursion is so much important to understand dynamic programming. That's why we will follow the same step when we will actually start the course. So these are the two different things that we are going to learn in today's class, right? So as I told you that I will be discussing about the content or the roadmap that we are going to follow. So in our content, when the actual course will start, I will start from absolute basic, and I will start with C++, the basic C++ concepts, the STL concept that you need to understand, why this time complexity, space complexity, and how to write them, pointers and dynamic memory allocation. So these are like the building blocks. These are like the pillars for learning, like jumping into any DSA course or any DSA thing, that like you can go jump into competitive programming, but if you do not know STL, you will not be able to write efficient code, right? So that's why these four things I will cover in a very like what I can say, in a very basic manner, so that I want to build the base at first. So after that, I will jump into searching algorithm. So there are searching algorithms like linear search, binary search, and not only that, we also have some other searching algorithms. So have you heard about interpolation search? Interpolation interpolation search. Definitely, I know you guys know about binary search, where you can go in O of n log n. Definitely, binary search is better. But do you know we can actually search a particular element in linear time, or not only in linear time, we can search something in constant time. In constant time. So if you are wondering and if you are thinking what I am talking about, can we search something in constant time? Like you cannot even imagine, and if you are able to imagine, then I guess you are able to understand the power of interpolation search. We can actually search a particular element in an array or in any data structure in constant time, in big O of 1. Especially there are some conditions, like the data structure, the array should be uniformly distributed. Whenever this is uniformly distributed, like an AP, I guess you know about the AP, right? So AP and this kind of sequence where we have like the uniformity, the numbers are uniformly distributed. So what I'm trying to say by uniformly distributed, uniform distribution is basically when the difference between two numbers are uniform or almost same or almost same. So when the numbers will be uniformly distributed, we can search, we can implement the interpolation search, which is like based on binary search, but it is much more efficient. So if you have not if you have not learned about this interpolation search, or there are also something called Fibonacci search. So definitely a lot of students, they know about linear, they know about binary search, they know how to solve like how to implement linear search, binary search. But in programming interview, like they will not ask you simply binary search, or then they will not ask you for linear search, or they will not even ask you for interpolation search also. Rather, they will ask you this question, and I have seen in last year, in the last year, in the same month, almost eight my student, they qualified in Amazon in 45 LPA in the last year itself. So they actually, when they shared their experience with me, they told me this particular question, that yes sir, so this question was there, like how you can search an element in constant time, can you search something? And when like they knew about this interpolation search, just thought about just like thought how to explain this question, because they know the algorithm, they know the code, so it will be very easy, right? So, and in our course actually I will be talking about all this code, and I will make sure that you will also be able to understand how to implement this code, all right, like the searching algorithm. Now, after discussing about the searching algorithm, it is very important to understand recursion, because recursion is the, like if you ask me what is the most important thing if you want to advance or if you want to level up your competitive programming, so in one simple word, recursion is the thing you want to understand. You definitely want to understand recursion if you want to understand like the dynamic programming, if you want to understand obviously greedy algorithms, definitely why we need it. And not only that, if you know about the tree data structure, if you know about the tree data structure, this tree is 100% recursive in nature. This tree data structure is 100% recursive in nature. Like whenever you want to implement any code in tree, you want to search something, you want to do anything, like there are a lot of things in tree and binary search tree, you can solve almost any problem if you follow the recursive paradigm. There is a very simplified structure that I have actually, after studying a lot, I have realized and I have implemented that. So this tree, and there is like graph concept, there is a lot of things where recursion which can only help you. That's why recursion is the most important thing to understand, and to like if you want to level up your programming skills. Now after that, we obviously we will be learning about sorting algorithm, because our course is actually not only course, like DSA itself is incomplete without sorting. Suppose you are there in your Amazon cart, and you are searching some item, definitely their searching will work. And when you are searching some item, many of you have actually used the option like the price from low to high. You have done in this way, low to high, or sometime you have done in high to low, the price or the popularity from high to low. In this way, you have customized your searching. And how this kind of thing are actually done in real life, and the answer is the sorting algorithms, how the sorting algorithm work. And definitely we know about bubble sort, insertion sort, selection sort. These are very simple sorting algorithms, and a programmer must know all the sorting algorithms. But apart from that, we also have like heap sort, radix sort, this sorting bucket sort, and there are a lot, shell sort, cycle sort. These sorting algorithms are the actual interview questions. So if you have mastered bubble sort, insertion sort, and selection sort, but if you actually want to crack interviews, so you have to understand a radix sort, cycle sort, cell sort, and all the other things. So this is what we are going to cover in the sorting algorithm part. Now after that, this number theory, you may know about mathematics, you know how to solve the number problems. In your class 11 or 12, you have studied algebraic problems. But in this number theory is a part where you can actually implement your that logic that you have learned, that algebra that you have learned, and you can implement it here. There is a very famous question called sieve of Eratosthenes. Sieve of Eratosthenes. This is a very famous question where we check the number is prime or not. Like we can calculate the prime number from a range. There will be a given range, and we can calculate all the prime numbers. And for solving this question, obviously we have our brute force approach, or we have our naive approach. But this sieve of Eratosthenes, this is a very famous interview question. And whatever guys, just let me give you a reminder, whatever I am discussing, if you are using pen and paper, go ahead and write it down, because I request you all that after this class, just go ahead and search it in the internet, because everything that is available in the internet. And the thing is, it is a little bit like what I have done here in this PPT. I have a 800 page PPT, almost 800, and near it is like 850 page PPT, where I have collected all the knowledge from different websites, and I have stored it here. But definitely, if you want to go there, search it, you can search it, and you can try to understand the logic. So sieve of Eratosthenes is there, and also after that we have something called segmented sieve. Segmented sieve. These questions are complex question, but like I have seen those who are in their final year also, they are not able to answer this question. I have seen a lot of interviewer, they are also like sometimes they are thinking about the question, okay, segmented sieve, what is segmented sieve? But I will make sure that you will understand all the complex logic around all the complex algorithms of number theory also. So this is what we are going to cover in number theory. And not only that, we also have a lot of thing in number theory. All the things that you can see, like the GCD calculation, the Euclid's algorithm, all the things that we are going to cover here. Now, the popular techniques for problem solving, you know, I guess some of you have heard about the two pointers algorithm, two pointers, and how to actually solve the two pointers algorithm. Hello. Yes, sir. No problem, sir. Just let me know. Ah, yeah, yeah, sir. I was talking about this algorithm, about these problems, that why these problems are necessary. So recursion itself is an important thing, and after learning recursion and after learning this particular thing, like the popular problems technique, like two pointers approach and sliding window approach, I'm going to cover this approach as well in the actual course, and there will be question in from this area. Just a minute. Hello, sir. Screen is not visible. Directly let me know, like if there is any problem, the screen is not visible or my voice is not clear properly. At any time, you guys can let me know. So now, as I was discussing about the popular technique, two pointer sliding window, after that I will jump into backtracking. So backtracking, what is backtracking and why we should learn backtracking? The answer is like whenever you will understand the recursion, and this backtracking is actually a optimization technique over this recursion. Like recursive problem, sometimes it can take a lot of time means the time complexity. So whenever this recursive problem, it will take a lot of time, you may want to optimize that particular code, like how to write the efficient code. So for that purpose, you will be using this backtracking algorithm. Popular interview questions like the permutations of a given string and int means problem. This kind of problems are actually example of this backtracking. After this backtracking, we will learn the greedy algorithms. Why greedy algorithms are important is sometimes following a simple greedy algorithm can give you a linear time result. So there are a lot of questions like, you know, the fractional knapsack problem. Knapsack problems are there, but fractional knapsack problem or job sequencing problem, activity selection problem, these are famous problem names, and these problems can be solved very easily using greedy algorithm, right? And if you are very new to data structures and algorithms, and if you are like wondering that what I am talking, some people you may understand, and some of you are might be wondering that what are these problems, how we can learn about these problems, because this is the roadmap, this is the exactly thing, this is the sequence in which we are going to learn our like if we are going to proceed. At first, I will start from here, then I will go here. Then, after discussing recursion and sorting algorithms, I will cover some number theory problems. Then, I'm going to discuss about some problem solving techniques like two pointers and sliding window. Then, we will use our recursive knowledge to improve our backtracking algorithms. And if you want to crack any like any company of more than 12 LPA or 15 LPA, you will be needing this knowledge. There will be questions from this area, and you have to answer the question. Like at least you have to tell them the algorithm that you will be implementing. Your thinking process should be there, and right. And as I will be covering a little bit of dynamic programming today, I'm just going to help you to visualize a dynamic programming problem or a recursive problem, because in the same problem, I will at first discuss the recursive solution, and from there, I will show you how we can convert any recursive code to dynamic programming code. Because this dynamic programming is just another optimization over recursion. Whenever there are two or more recursive calls, we can optimize the code. Like we can, what I'm trying to say by optimizing means I can actually write in few lines, or I can write I can take less time. And what is this time actually? This time is not the time that like that we see in our watch, or how much minute or how much seconds it's gonna take. This time is independent of that time. That it's kind of a function that which is independent of any machine. Any people, they can have a RAM of 8 GB, and they can have a SSD. And let's say I'm having a RAM of 2 GB, and I do not have any SSD. So definitely the same program that will run faster in their computer, but this time complexity is actually independent of that. It's like a function that will help us to say that whatever is the thing, if I give this amount of input, it will take this much time to execute the code. So this dynamic programming will simply optimize the code, or optimize the recursive code. There are two methods. One is top down and another one is bottom up. I'm going to discuss both the methods in the actual course. Now, when you have understood all these things, when you have learned these concepts and you have mastered this concept, we are going to go in our next part of our content. So the next part there, we will be learning about bit manipulation. So what is bit manipulation? Or some people call it bit magic, some people call it bitwise operators. But bit manipulation is basically when we study the bits 10010. In this way, we will divide the number. We will actually break down the number in bits, and there we will perform some operations. So why bit manipulation is necessary? Because we know that computer understands only these bits, zeros or ones. I'm not talking about the quantum computers. Normal computers, they understand only these bits. And if we know how to manipulate, how to communicate directly with the bit, that will be very faster. Like whatever code we can, the same code can be written using a simple algorithm, and also using a bit manipulation algorithm, or using bitwise operators. But or a lot of programmers believe, or you can see a lot of articles that where you are using the bitwise operator, that code will be a lot faster. So that's why we have to understand the bit manipulation. And not only that, like popular interview questions like are from XOR operators or the bitwise OR operator. There are a lot of programming interview questions like two unique value, one unique value. This kind of interview questions are there. Okay, so after that, heap, binary heap, we can also say binary heap. This is also another part. And not only this binary heap, that like the in STL, in C++, there is a thing called priority queue. Right, let me write it. There is a thing called priority queue. So whenever we have this priority queue, in there we can implement actually the heap using priority queue. In heap we have our max heap and we have our mean heap. We have both the things right there, max heap and mean heap. How to implement them and how to solve some array questions easily. Like the question will be of array or string. So a lot of time you will see the questions of arrays or the questions of string, and if you solve them using simple like loop concept, using for loop or using while loop, it will take on square or on cube time. But we can solve the array question very easily, like in 2 to 3 lines of code using this priority queue. A lot of time we are going to see that. And not only that, we also have hashing. So hashing is also another algorithm, and the data structure behind this algorithm is known as hash table. Hash table. So this hash table is the second most used data structure. So what is the first used data structure? The most used data structure in the programming world, it is array. And after array, this hash table is the second most used data structure. whenever you want to implement some encryption concept, you want to encrypt something, decrypt something, you want to store something in key value pair, there you will be needing this hashing a lot. And in our STL, obviously we can do that very easily. After that, we have our stack and queue. You have heard about the stack and queue, the DQ. You have heard about all these things, and we are actually going to dive deep into the concept of stack, queue, and DQ. Especially, I will be focusing on the interview questions. All right, and when we have mastered this concept, now it's time to like understand the most awarded thing like the linked list and graph and all these concepts. So linked list is like a building block to understand our tree, because what we have learned so far is like a memory where the memory will be allocated contiguously in arrays or in string. All the memories will be just the block will be one after another. Whenever, let's say, you have a block something like this, let's say, just a minute, you have let me draw it. So let's say you have the array, and the array will be something like in this manner. Okay, so the elements are, let's say, 10, 20, 30, 40, and 50. We have the elements in this way, and in array we know it is indexed. That means what? Like the first element will have the index 0, the second element will have the index 1, 2, 3, 4. In this way I will be having all the elements. And if the number of elements we have, it is given in the question that we have n elements in this array. So here in this particular array we have 1, 2, 3, 4, 5 elements are given. So when these 5 elements are given, the last index will be n minus 1, that is 4. This is what will given to us, and this will be in our main memory. All the elements, all the blocks, they will be just one after another. But in linked list, what happens is we kind of form a node-like structure where there are two things at the same place. Like I will be having the data value. 10 is the data value, let's say, for the first one. And after that, I have one more like space. And this space will store the address of the next node. Okay, so address. So what I'm trying to say, let's try to visualize it. So let's say this is the free space in your RAM. Okay, this is the entire space that you have in your RAM, in your main memory. And if you can actually fit this particular array right here, it is okay, no problem with that. But what if this particular place is occupied, and this place is also occupied, and now you want to, this places are actually occupied, you cannot use those places. So can you, if you want to fit an array, if you want to store some elements, it is not possible to use this space and this place simultaneously, because in array we have to form something like this should be contiguous. So, or like all the memory blocks should be one after another. So now what we can do is we can use something like a linked structure, that this memory, it has a unique address, this part also has a unique address, so we can connect them. This is a block, and here I can create one more block, here I can create one more block, here I can create one more block. Let's say this block is connected with this block is connected with this block, and this is connected with this block. So now you can see I have actually formed, I have stored all the elements that I can store in an array, but I am using some random memory. I'm not using the continuous memories. So let's say I'm storing 10 right here, and after 10 here I am storing the address of the next node. I am storing 20 here. So this 10 is connected with this 20. There is a connection in there. And what is the connection? I am storing the address. Now here I am storing the address of another node. This will be the address of another node. From there I can store the address of another node, and it is not important that we should draw the linked list in the linear fashion only. These nodes can be anywhere in the memory. So this is what we mean by a linked structure, where we have a node. So how this node will look like, basically we can implement it using a structure, or we can also implement it using class. In C++, we have both the things available. I will focus on class implementation, so that after learning linked list, when I will go for tree or binary tree, you will be able to understand it in a very good manner. So guys, if you guys have any question, if you guys have any query, in between you can just like communicate with me also. Just you can let me know to our sir, and he will actually communicate with me. Definitely, if you guys have any query that like if you want to ask me, sir, will are we going to learn this also in our course, are we going to learn this also in our course? So if you want to do that, definitely you can ask me anytime. Just do not just like sit and watch that what I am doing here, what I am writing here. You can also communicate with me and also try to understand, because this is the roadmap, this is what we are going to learn. And I will also tell you that how much time we should give if you are planning for a like if you are planning to learn it independently, you want to start from today only. So I will also tell you that how we can do that, how you can actually do that. All right. So this is what we have after learning linked list, that how to implement this structure. We have a linked structure, we have another linked structure. So after that we can actually implement this tree. But before tree I prefer like before discussing tree I prefer to discuss the graph concept. And especially you can see graph algorithms 1, we have also graph algorithms 2 after that. So what is a graph? Basically, a graph is suppose let's think about the road network or the airplane network. So let's say here I have Delhi airport, here I have Kolkata airport, here I have the Bangalore airport, here I have the Chennai airport. So all the airports I have written in this manner. So suppose you want to say that there is a flight from Delhi to Bangalore and the rate of the flight is 3300. This is the rate of the flight. And suppose there is another flight from Delhi to Kolkata and the rate of the flight is let's say the flight is something like 200 2200. This is what 2200, this is what the rate. Definitely it's not possible in today's world, but suppose just think about it, we have this particular thing. And from Kolkata we have one more flight coming here in this Bangalore and the rate is 1000. Suppose for any offer or any coupon you have and you are getting in this manner. So will you follow a direct flight if you are in a budget trip, if you are planning for a budget, even if you are satisfied that you can save 100 rupees? So definitely at first you will go from Delhi to Kolkata and from Kolkata to Bangalore. You will follow this path. Now how to represent this kind of network, how to actually represent this network, and the answer is graph theory. We can represent this kind of road network, this kind of any kind of network using graph very easily. Now in real life we have the connection very deep, like there are a lot of nodes. Like the flight can go from Delhi to Bangalore, this can be directed or this can be undirected. Like the fare is same. When I want to represent that the fare is same, the price is same. If you want to go from Delhi to Kolkata or Kolkata to Delhi, the price will be same, then I will represent in this way. But if I want to specify one way, so I have to represent, I have to give this arrow. So this kind of structures are there. These are called the nodes or vertices. This particular links, they are called the edges in our graph theory. So I will show you that how to represent these graphs in real life and how to actually code them. There are a lot of implementation. There are implementations like edge list implementation, adjacency list, adjacency matrix. We will discuss all the things. Also traversal, like if you are starting from here, you are starting from this point, this is your start point, and you have to visit all the nodes of this particular graph. You have to visit this Delhi, then Kolkata, Chennai, Bangalore in some order. So then how to traverse them? There are algorithms like BFS, there are algorithms like DFS. We have all these algorithms and we are going to discuss that. You have to learn that. And also suppose your graph is something like the graph is connected in this way, like it has some direction, and we call such graphs as DAG, directed acyclic graph. When there is no cycle here, if it is forming a cycle, it will not a DAG, directed acyclic graph. If the graph is directed for and there is no cycle, it is given in the question, we can traverse them in some order, and this is known as topological sorting. Topo sort, we call it topo sort, the topological sorting. This topological sorting can also be done in BFS and DFS. After that, there are shortest path algorithms, Dijkstra's algorithm, Bellman-Ford algorithm. These are all shortest path algorithm. And whenever you are learning graph theory, you have to understand at least this concept, that how we can implement a graph, how we can represent a graph in our code, how to traverse the graph like using BFS or using DFS, and how they are like recursive. Because if you remember, I discussed about the recursion. So how they are recursive, this BFS and this DFS, topological sorting, everything is kind of like connected, how they are recursive in nature. We are going to discuss that. Now when this graph algorithm part 1 is finished, okay, when this is finished, we will learn about the tree. Because in tree also, how a tree can be done, because here we do not follow the linear fashion, we also have hierarchy. Because in array we cannot represent the hierarchy or a folder structure kind of thing. Everything is continuous, everything is linear. So in hierarchy we can basically have nodes in this manner. We have a tree, we have this node, we have this node, this and this, they are the children of this node, they are under this node. So this kind of hierarchy can be implemented using tree, using graph, anything. So you can actually write in this manner, you can write in this manner, you can draw. This is also a valid tree, this is also a valid tree. And also, if I can tell you, this is also a valid graph. There is no difference between a tree and a graph, because a tree is a special kind of graph. A tree, let me tell you once again, because there are interview questions something like this. I'm telling you, this is something like this. I have seen interview questions like this also. This is a first figure, this is figure 1, and I have a second figure, this is figure 2. An interviewer will ask you that which one, figure 1 or figure 2, which one is a graph and which one is a tree. So generally people, they say that this particular thing is a graph and this particular thing is a tree. Or if you are trying to be over smart, like if you are planning, okay, so if the interviewer is asking me this question, there might be some twist. So if this is a graph, then I will tell that, okay sir, this is a tree and this is not a graph and this is a graph. I will tell in this manner. But the answer is both the things are trees and both the things are graphs as well. It matters, what actually matters is actually the representation, how you are representing these nodes and how you are representing these edges. Both the things are trees and both the things are graph, because tree is a special kind of graph only. If you know what is a graph, like where we have these nodes and where we have these edges and where we can have the connections in a hierarchical manner, then it is a graph. And these trees are actually graph. Actually, that's why we studied graph before trees, because this is a very conceptual thing. Whenever you are actually learning DSA, you have to visualize the concept. If you are not able to visualize it, you will not be able to solve the problems as well, right? So in tree, what we are going to cover, so in tree we are normally the representation, traversal, this is what we are going to cover. After that, in tree specially, we are going to cover binary trees. What is binary tree and what is a normal tree? The difference, like a binary tree is where we can have at most two children. So you can see this node has two children, this node has one children, this node is not having any children. So this is a binary tree. We can say this is a binary tree. And suppose we have this particular thing. Here we can also have some nodes. There are some nodes here. This is the parent node, and the common way to represent it as this is the root node. These are the children. This is the parent. This is the child. We have this kind of relationship. So this is not a binary tree, because this node, this node, this node, they all are having a same parent. A parent is having more than more than two children actually. So that's why this particular tree, it is a tree, but it is not a binary tree. A binary tree is where it can have zero child, one child, or two children. Then we call it a binary tree. So we will be specially learning about the binary tree, and after that we will actually solve some LeetCode problems. LeetCode is a very, if you do not know, LeetCode is a very famous problem solving website. So we will be following LeetCode mostly because many interviewer can actually ask you the LeetCode easy problems directly. you may have directly the live code easy problems in your interview or in your the coding round of any company. So that's why I prefer live code, and a lot of people prefer live code. So after that, we will be learning about binary search tree. You can remember we have learned about binary search algorithm. Binary search algorithm, and if you are implementing the binary search algorithm in case of trees, so then we will learn binary search tree. So what is a binary search tree? It is very simple. Let's say we have this root and we have a value of 10 here, and we can have another node here, another node in. This is the left node, this is the right node. We can have both the nodes. So if this value is 20, this value is 9, definitely it is a binary tree. We can say this is a binary tree, but this is not a binary search tree. This is not a BST. Why? Because the definition is all the nodes in the left side must be smaller than the parent, and all the node on the right side must be greater than the parent, and this condition must be true for all the other nodes. So suppose I have this particular tree, I have 10 here. So the left child, the value for this particular node must be smaller than this 10. So I can have 9 here. Right here in this direction I can have 11 here, and the value can be from 9 to negative infinite. We can have any value, from 9 to, this is the range. And why I'm talking about this range? Because this is a very another important question. You will be learning an interview question, like whether a tree is a binary search tree or not. This is a very famous interview question. Any tree is a binary search tree or not? So there, like in tree traversal, there are methods like in order, pre-order, post order, and all this in order, pre-order, post order, these methods are actually DFS in case of trees. We also have PFS in case of trees as well, and that is nothing but the level order traversal. Level order traversal. So you can actually follow the in order traversal, and if the in order traversal of any tree is sorted, that is a binary search tree. But there is also one more famous method like the range. The left node, it must be smaller than this root node. So it must be smaller than 10, but the value can be anything that is smaller than 10. So the range is from minus infinite to 9. This can be the range. And from here, the range can be from 11 to positive infinite. The range value can be anything. Now if I go here, if I'm going in the left direction, this value can be anything, and this value must be smaller than 9. This is the only condition. So this value can be minus infinite to anything less than 9, so 8. This can be anything. So I can have 8 here, I can have 5 here also. Any value can be there. And for simplicity purpose, we will not what we are not going to cover. We will not cover duplicate values, right? We are not cover duplicate values. We are not cover floating point numbers. Rather, if you want, you can definitely have floating point numbers. You just have to customize the class node structure a little bit. Also, if I am going in the right direction, so what can be the value? The value should be greater than 9 but less than 10. So definitely I cannot have such value because I am not considering floating point number. So there is no valid valid value available for this node. So if I customize this a little more, let's say I am adding here. Let's forget about this range now. I am adding 6 here. So is this a valid binary search tree? Yes, it is 10, and 6 is less than 10. And if I go in the left direction a little more, so this value is 5. It is also less than 6, so it is a valid node. And if I write here 8, so now you can see this entire subtree, this is known as a subtree. All the nodes are smaller than 10. This is true. Now 6, if it is the root node, if it is the parent, the left node must be smaller than 6 and the right node must be greater than 6. So this condition is also true. So since I am having all the conditions true, so I can say this is a proper binary search tree. In this way you can implement a binary search tree on your own, and you can check it out in the internet whether it is a binary search tree or not. Okay, so this is what is binary search tree, and there are a lot of algorithms that we are going to cover. So now when we have understood our content too, we have understood bit manipulation, heap, hashing, and stack, queue, graph algorithms, tree. then we are left with this try. So try is a advanced data structure which is used to implement dictionary. Now it is very complicated to discuss about try right now, because if I do not discuss about tree a lot, and I do not tell you about how it works, the traversals, you will not be able to understand try in a very simple manner. But for now, you can understand in this way, like whenever you want to implement some dictionary, something like that, where you want easy searching, easy getting the value, then you will implement try. And we are also going to cover, and you also should learn this try data structure after our content 2. Next part is a much more advanced part, where you also should know about this part. What is it? You should learn the segment tree and binary indexed tree. When big trees concepts are there, a lot of things are there, but segment tree and binary index tree, this part are basically to solve array questions very easily. Also, we have our graph algorithm part 2, graph algorithm part 1, where we have the representation, BFS, TFS, traversals, the simple things. Here we are actually going to, you can see the directed graph, the directed, especially the directed acyclic graph. We are going to uh, actually discuss about this, and especially the topo sort that I discussed, the topological sorting. So topo sort is not a sorting algorithm. You may wonder topo sort. It is actually like what we can say. We call it the dependency wise sorting. When I will actually discuss the algorithm, you will be able to understand. But don't get confused. It is not a sorting algorithm. It is like a graph traversal algorithm used for directed acyclic graph. Now, for strongly connectivity, whether a graph is strongly connected or not. What do we mean by strongly connectivity? Like whether all the nodes are reachable from each other or not. You can see this particular graph. This is a undirected graph. That means there is no direction in the edges. So if the edges are directed, if this is directed, you can see I am having this kind of direction. Okay, I am having this kind of direction. Let me draw it in a better way. I have this node. From here I have this node. From here I have this node, and I have this, and I have this. Okay, and also let's say these are independent, they are not connected. And also if they are connected, that can also be done, no problem. But it should be directed graph, and there should not be any cycle. So is there any cycle forming? Like we can say I can go from here to here to here, and I can go to here. So definitely I cannot go from this node. If I start visiting, if I start traversing, I can go to this node. I can visit this node, I can visit this node, I can visit this node. But there is no cycle, like I cannot return to this node if I start from here. And if I start from here, definitely from here I can go to this node, and I can go to this node. So obviously I can visit all the node, and there is no cycle for me. So now guys, I'm requesting you all to draw a directed graph. Just draw a directed graph, and just for practice, and then I will be covering the next part of the program. I will just going to cover it after a few minutes. Okay. Okay guys, so now as we have understood this, after that definitely we have some paths and circuit. This is a network path and circuit. These are some advanced ones. And obviously, how can we miss game theory? Because if we go for bit manipulation, after that we have something called name game. The name game concept is also there. So when I will go for name game or game theory, it will be a very interesting concept. And we are definitely going to cover this name game when I will be covering you the bit manipulation part only. There only I will be covering the name game or game theory part. It's a very simple game theory problem asked in very famous interview questions, like can you actually implement name game? This is also a valid interview question. And also range queries are there, just like segment trees. These questions are there for solving solving the array questions. We have also range queries, right? Also some other string algorithm. String is what, although it is written right here, but it depends on my students. So if you are very interesting, if you are very engaging. So I will be covering this string algorithms before, only before where it is written, because this is an advanced part. We have some string questions, a very popular interview question like LPS array construction. LPS array construction. This LPS array construction is basically when we have some string algorithms or pattern matching algorithm. Pattern matching algorithm. Okay, so whenever you do Google search, whenever you search something in the Google, you may think that you are just typing something and the pattern, whatever the word you are searching, you are getting it. You are in a PDF document or you are in a Word document and you are searching something, and all the thing that will be highlighted, the prefix searching, all this kind of pattern searching algorithm. We have a lot of pattern searching algorithm. So, like we have some KMP algorithm, no Smurith-Pratt algorithm. This KMP algorithm is a very, very important algorithm in string searching or pattern searching, pattern matching, whatever you want to call it. After that, we also have some Rabin curve algorithm. Rabin curve. This Rabin curve is also a string matching or pattern searching algorithm that we use. And apart from this KMP and Rabin curve, these are popular interview questions. Like in any interview, you can, there is a high chance that you will be getting this kind of questions directly. That can you tell me KMP algorithm? Can you tell me what is Rabin curve algorithm? There, what you have to do, you just have to tell the algorithm, the steps, and we are going to cover that. But before KMP and before Rabin curve, before discussing that, we are going to cover the naive algorithm. Okay, we are going to cover the naive pattern searching algorithm and also how to optimize it, because optimized naive algorithm sometimes overperforms this kind of outperforms this KMP and Rabin curve also. This is much better, the optimized version. Also, apart from that, we have Maneker's algorithm for palindromes, and there are a lot that we are going to cover. All right, so this is like overall like we can say the content. Square root algorithms are also there. Disjoint set, I'm going to cover this disjoint set when I will be talking about the Kosaraju's Prim's, after Prim's algorithm, when I will be talking about the Kruskal's algorithm in graph theory. In graph theory, I will be talking about the Kruskal's algorithm and also Prim's algorithm. So when I am going to talk about this Kruskal's algorithm, there I am going to discuss the disjoint set. And also we have something called Kosaraju's algorithm. So if you are hearing the algorithm for the first time, don't get confused, because all these are very famous interview questions. All the algorithm that I have talked so far, all these things are easy, very easy to understand. Just you have to follow this path, this kind of thing one by one. And this convex hull, this is a geometry based question, the line and convex hull. This is after learning all these things. These are some bonus topic, bonus kind of thing. These are not covered in all the interviews. These are just some bonus kind of thing. So yeah, this is the overall problem, overall syllabus that we are going to cover from start to end. This is what we are going to do. We will be starting from absolute basic, exactly the basic concepts will be there, and slowly one by one concepts we will pick, one by one algorithms we will pick, and we will master those algorithms. So this is it. If you guys have some question, if you guys want to ask something that whether this concept will also be there, this is also be there, you guys can directly ask me anytime, no problem with that. All right. So now, after I guess you have understood the roadmap, that how you should learn and what are the contents, what are the important content, the concepts. So now, I'm going to discuss about some specific problem. Actually, I'm going to talk about some interview questions that have been asked in previous year. These are very simple interview question, and as I already discussed in the agenda part, that I will be talking about the sliding window and I will be talking about the dynamic programming. I will discuss two problems. One problem is from sliding window, because in problem solving technique you can see in our content one, you can see popular techniques for problem solving. Right here you can see. So from here I will be talking about the sliding window problem, how it is and what is the inspiration to solve this problem. I will be discussing that. and a very simple algorithm. And I will show you the pseudocode. After that, I will request you all to write the code on your own. If you have any little bit idea of C or C++, you guys can easily write it. Okay, so the first thing is sliding window. The name is very common, like I guess you all have seen the aluminum sliding window, something like this in our home or in some office. This kind of thing slides, and we have some opening. This is known as the frame. These are all the glasses, and this is the slider. You all have seen this kind of sliding window in our real life also. In our programming life also, this kind of sliding window actually is there. Whenever you want to implement sliding window problem, it is very important to visualize this kind of thing. Now just think about this array I'm writing here, I'm drawing here. This is a simple array, and the elements are 10, 20, 30, 40, and let's say 50. We have some elements. These elements are there, and also you can also have one more element, let's say 5. So I have these elements right here. So now if I actually form a window kind of thing, and this window is nothing but the sub array of this original array. Okay, so this is a sub array. If I have this entire thing as the original array, so this particular thing is the sub array. Alright, you can see this particular thing is the sub array of the entire array, and this part can be represented as a window. Okay, this can be represented as the window. And what do we mean by the sliding window? Sliding window means when this particular thing actually slides, just like the animation I had shown you. When this window will slide from here to here. So the size of the window, you can see the size is fixed. The size is fixed. The size is that there are only two elements can fit. This is the size that is fixed. So it is just sliding from here to here. Now it is covering two more elements. So this is actually known as the sliding window technique. When you slide this window or use the size of the sub array to do something, to calculate the sum, to calculate some other properties when you create the window. Now there can be two kind of questions. One can be when the size of the window is fixed, and another can be a variable sized window. I'm not going in some technical terms, rather I'm just going to discuss a very simple thing. Like here also you can see the size of the window is fixed. The questions that can be solved in n square or n cube time, when you implement the sliding window technique, it can be solved in linear time almost. So that's why in this way you can see the animation right here. Like I have this window and the window is sliding, and whenever this window is sliding, at any time when the window is here, you can calculate the sum. You can break the problem in parts and you can actually solve. You can like step by step you can solve the problem. So that's why it is known as the sliding window. You can see this, it is sliding. The window, that is the sub array, is sliding, that is it is moving. Okay, so now let us see a problem. Basically the problem is here how to represent this sliding window. I will show you that also. And this is the diagram before before learning the problem, and I will give you the problem. It is very important to know how to represent the sliding window also. So in any array, you can see in this particular right part, I have this entire array. Let's say I have all the elements right here. Here I have some elements. And when you are actually trying to implement this sliding window, you have two pointers. You have two pointers. Pointers are not like the memory pointers, memory level pointers. These pointers are just index number. So here I have my I, and here also I have my j. Both the things are some index. I is equals to 0, j is also equals to 0. So both the things, they are representing the same element. Let's say I have 10 here, I have 20, 30, 40. In this way, if I have the elements, so it is now representing only the first element. Now if you want to increment the size of the window, whenever you want to increment the size of the window, then you have to increment the value of j. So if j is pointing, j is equals to 1, so it will not point here, rather it will point here. If j is equals to 2, it will point here. So how the window will look like? The starting point of the window I equals to 0, and the ending point of the window j equals to 2. So in this way, you can increment the window or increment the value of j one by one. And now at this point, if you want to slide the window, if you want to slide the window, what you can do is you can actually increment the value of j plus plus, and as well as you can increment the value of I plus plus. So if you do that, you can see this particular I will become 1. Initially it was 0, it will now become 1. So I will point here, this will be the new starting point of the window, and j will also increment, the value of j will increment whatever. If it is 2, it will be 3, if it is 3, it will be 4, if it is 4, it will be 5, whatever is the value. In this way, we can slide the window. Earlier it was actually in this region, and now it is in this particular region. So we can increment I as well as we can increment j. We can increment both the values to slide the window, and to change the slide size of the window, you just need to change j. This is what you have to do. I guess you are able to visualize it. So now let's see, when I have I and j both are 0, you are changing the size, and after changing the size, you are doing j plus plus, j plus plus. So I is still here and j has come here. So you are initially j was also here. You have incremented j. You have incremented j in this way. After incrementing it 2 times or 3 times or 4 times, j has come here. So now this is a matured size window. This window size is now the desired size that was there in the given question. In this size, if you have the starting point, if you have the ending point, you can easily calculate the sum, you can easily iterate this particular sub array, and it is much more easier. Why? Because if you have to traverse from here to here, and if you have to traverse multiple times, and here what you are doing, you are just traversing this sub array once. So in the real problem that I will show you, there you can see that how much efficient it will be. So here now, when the window size is matured or the window size is fixed, there what I have told you, that just increment I as well as j to slide the window. Increment I as well as j. So if you slide it, you can just visualize it. I is pointing here, j is pointing here. If you increment I and j, this window will slide a little bit. This will be the desired size. So from here, the window will slide a little bit and we will be getting here. You can also increment the value much more. You can also increment the value much more to get the actual size. Now, let us talk about the actual problem. And also here, like in this problem also, I will give you the explanation part, or I will help you to visualize the problem once again. This particular thing is a very famous interview question. And if you listen to me very carefully, I guarantee you, you will be able to not only write down the algorithm, but also you will be able to write down the entire code on your own. You can go to any online coding platform like LeetCode, CodeChef, or HackerRank, HackerEarth. There are multiple things. You will be able to do that. So what is the question? The question is maximum sub-array sum of size k. Maximum sub-array sum of size k. So in almost every sliding window problem, there will be this kind of keywords. The question will be of either sub-array, okay, or substring. Either sub-array or substring. The question will be of sub-array or substring. So here you can see maximum sub-array. So you can see this keyword sub-array. And also there will be this k. K is what? K is the size. So you can see the size of the window is given as k. In your real life, k, the value of k will be given. K will be 3, k will be 4. Any size of the window will be given. So now, if this is the problem statement, can you now imagine that what the problem is actually stating? So if you are not able to properly imagine, let me actually show you that what is the problem statement. And listen to me very carefully, guys. Please listen to me very carefully. Focus right here. This is the actual problem. How to solve this problem, you will be able to understand. So let's say this is a particular array that is given to us. This is the particular array. All the elements I have shown using blocks. You know how to use the sliding window concept. The sliding window, like I can initialize I and j, both will start here. I can increment the value of j one by one to increment the value of window, to increment the window size. Then I can increment I as well as j to slide the window. This is what I can do. Now what is the question? The question is, I will be given some array. I will be definitely given some array, and here you can see how I am sliding the window. When I'm sliding the window, I am actually including some element, and this element is now like whenever I'm sliding it, I'm incrementing I as well as I'm incrementing j. You can see this element is excluded, and a new element is included in our region. This is what we can do. Now let's talk about this problem in a much more easier manner, or the actual problem kind of thing where you can understand. So let's say we are given this array 5, we are given 10, we are given 3, we are given uh, 7, we are given 9. So this is the array. This is the array. So the question is maximum sub array sum. We have to calculate the maximum sub array sum, and the size of the window will also be given. The size of the window is, let's say, 2. This is the size of the window that is given. The value of k is equals to 2. This is given to us in our problem. This window size will be given to us. So if I calculate manually, so window size 2 means the sub array size will be 2. So how many sub arrays I can form this particular array of size 2? Definitely 5 and 10. This is a sub array. I can form also 10 and 3. This is another sub array. I can form 3 and 7. This is another sub array. I can form 7 and 9. This is another sub array. Alright, I guess you are getting it. Sub arrays of size 2. This is what I am doing. 5 and 10 is a sub array. 10 and 3 sub array. 3 and 7 sub array. 7 and 9 sub arrays. So I have all the sub arrays right here. So now when I have all the sub arrays in this manner, what I have to do, I have to calculate the sum of all the sub arrays. So if I calculate the sum, it is 15. If I calculate the sum, this is 13. If I calculate this sum, it is nothing but 10. And if I calculate this sum, what will be the sum? The sum is 16, right? These are the values that I am having. Okay, actually it is 17. No, 6. Also, I'm so sorry. I was confused a little bit. I get confused in this kind of simple calculation sometimes a lot. So this is 16, and this is 10. This is 13, and this is 15. So now if I have all the sub-arrays and their sum, what is the maximum among them? So obviously this particular thing is the maximum among them. So this will be the answer. This is what we are going to return, right? So now if this is the thing that we are going to return, how to actually approach this problem? So what I will be doing, or what can be the best approach, you can actually try to think the naive approach, but what can be the best approach and how to actually use this sliding window. You have understood, I guess you have understood that whenever I'm sliding this window, a new element is getting included and the old element, we are excluding the element. This is what we are continuously doing. But how we will use this logic? So whenever we are adding this window, whenever we are incrementing the size, whenever you can see this element, I am getting the new window, or I am getting the new sub array, I will just add this value and I will subtract this value. So now let's see the pseudo code, and let me also show you the dry run of this particular code. Let's say we have some elements, we have all the elements. Let me write all the elements right here. We have 3, we have 2, just a minute. We have right here, we have 3, we have 2, we have 5, 9 and 10. We have again 1, then 2, then 3, then 7, and then let's say it is 6. These are the elements, and this is the actual result. You can see this particular window of size k is the size that is given to us as 3. In our question it will be given to you that maximum subarray sum of size k is equals to 3. This is what you have to calculate. Now according to our problem, what I will do initially, I will initialize I equals to 0 and I will initialize j equals to 0. So I and j both will start pointing, to this first element. They will be pointing to this first element. This is the initial window. All they are pointing in this region. Now after that, what I will do, I will also take another variable, sum variable. This sum variable will hold the value of the sum, because I have to calculate the maximum among them. So sometime in our C++, we have a function called max. This is in STL. Basically in C++ STL we have this max. Using this function we can calculate the maximum, right? So I will keep updating the maximum value. And also initially the max variable will have the value int mean. So this int mean in C++ it is equivalent to minus infinite. This is negative infinite and nothing else. So we have done all the initial thing, like I have initialized I equals to 0, I have initialized j equals to 0. That means both the thing are pointing to the first element. I have the sum. This sum will hold the value of the current window. This sum will hold the value of the current window, and this mx, this max variable, will hold the global maximum value, like maximum of all. Let me again tell you, this sum variable, this sum is of the current sum, this is of the current sum, okay, the current sub array sum, and this mx is the overall sum. This is the overall sum. I will update this mx when the current sum will be greater. This is what I am doing. I guess you are able to understand. Let me tell you once again. I have initialized I and j equals to 0 because I am trying to represent the sliding window. I have the sum variable. I have initialized it with 0 because current sum is 0. I have got it. And the max variable, which is global, and overall I have initialized with negative infinite, because sometimes the value can be negative as well. That's why I'm not initializing it with I'm not initializing with 0, because the first element can be negative, and if all the elements are negative and the first element is the lowest negative, then that will be the maximum value. So that's why you always should use, whenever the question is of maximum, you should always use int mean. Whenever the question is of minimum, you should always use int max. Okay, whenever the question is of maximum, you should use int mean, and whenever the question is of minimum, you should use int max. Right now I am just running a simple while loop while j is less than k. What is k? K is the size of the window. What is given to us? The size is 3. And what is the value of j? The value of j is 0. So is this condition true? 0 is less than 3. Is this condition true? And this condition is true. So when this condition is true, I will go inside this particular loop and I will increment the value of sum with array of j. J is what? J is the index. J is what? J is index. And array of j is what? Array of j is the element. Okay, so I guess you know j is index and array of j is element. So I will increment the value of sum with array of j. What is j? J is 0. J is right here. Okay, so j is right here. J is 0. Sum initially it is holding the value of 0. So I will increment the value of sum. So what will be the new value of sum? I am writing it here. The sum will have the value 3. Now after doing that, I will check if j minus I plus 1 is less than k. Why this condition? This condition is checking whether we have got the desired size or not. So let me tell you once again. Just let me tell you once again with the help of one more example. Right here, let's say I have this particular window. I am drawing one more window here. Let's say I have this particular window. Okay, this is our array and this is our window. These are the elements. These are the elements, and this is my window. Alright, so why? Let me tell you the meaning of j minus I plus 1. Let me tell you the meaning of this j minus I plus 1. You will be able to understand. So why j minus I? This is 0, this is 1, this is 2, 3, 4, 5 and 6. These are all the index number I have written. Now we know that I represent the starting point of the window, j represents the ending point of the window. I represents the starting point of the window, j represents the ending point of the window. So if you actually carefully look right here, you can see I is currently pointing at this 2. I is pointing here. J is pointing at this 4. Okay, j is pointing right here. So 4 is our j. I is pointing at 2 and j is pointing at 4. So what is the size of the window? Since in array we follow zero-based indexing, since in array we follow zero-based indexing, so that's why the size will be what? The size will be this 4 minus 2 is equals to 2 plus 1, because we are following zero-based indexing. So you can see the size is 3 and it is actually matching 1, 2 and 3. So that's why whenever you want to get the size is basically j minus I plus 1, and also the size will be given to our question. The size is k, so I can compare this k with j minus I plus 1. That's why we are using the comparisons, like using if. These are the conditionals. We are using the comparison operator, comparator, and what we are using, we are using either greater than, either less than. We can use any kind of this comparison operator to get whether the size is less than, greater than, or equal to. If it is equal to, I will stop incrementing the size, and rather what I will do, I will slide it until and unless I have got the desired window. What I will do, I will increment it. I will increment the size. Initially it will be here I and j both will be 0. Now I will increment, and when in the question k, the value of k is given to us, when k will be 3, I will stop incrementing the window, because at that time j minus I plus 1 will be equal to k. I will stop incrementing and I will start sliding. And how to start sliding? I will do I plus plus and I will do j plus plus. So let me get back to the actual question. And for that purpose I have to just remove this, because a lot of things are written there in the slide. Because guys, if you have any question, you can write it down, and after some time you can actually ask me. If you guys have any question, please write it down. I request you all to write it down if you guys are having any question. Okay. And if you are liking the session, please give the feedback. If you are understanding whatever I am talking about, please give the feedback. So here I am right here. I'm right here in my code. So what I was talking about the sliding window concept. So initially I and j both are 0. And this condition j minus I plus 1, what will be the value of j minus I plus 1? J is also 0, I is also 0, and it is 1. And what is the value of k? The value of k is 3. J minus I plus 1 will be 1 and it is 3. So have we got the desired window? No, we have not got the desired window. That's why I will not perform this statement, this j plus plus statement. I will not perform it. Why? Because this condition is false. And according to if else condition, if this condition is false, only then I will execute this statement, right? Now after that, if this if is false, I will go ahead and I will check the else if condition. In else if condition, I am checking whether I have got the desired size window or not. So for this question, this definition, the explanation will be different, but I am actually talking about this particular thing. If this condition is false, I will not go ahead, I will not do that. If j minus I plus 1 is equals to, what is j minus I plus 1? For this one it will be 1. Is it equal to 3? I will check this condition. If this condition is true, I will at first do this, I will do this, I will do this. So this part is for sliding, and this j plus plus, this is for incrementing. Now can you tell me whether 1 is less than 3? And this actual answer for this question is yes. For this question, for now, 1 is the current size and 3 is the desired size, and this condition is true. So what I will do, I will simply go ahead, I will do j plus plus. I will not go inside this elif because if is true. So I will increment this window size. Now j is right here. J is equals to 1. So now j is equals to 1. I will again check this condition. If j is less than k, so what is j? J is 1. What is k? K is 3. Is it true? Yes, the condition is true. So I will increment the value of 2 also with the previous value of sum. So with sum, I will add 2. So the current window sum will be 5. So now the current window sum is 5. Now when the current window sum is 5, what I will do? I will again check this condition, j minus I plus 1. Now what is j minus I plus 1? It is 2. and 2 is again less than 3, so I will increment the window. So the window will look something like this, and again I will add this 5 with this previous 5. So what will be the value? The value will be 10. I guess you are getting it. The value will be 10, and when this value is actually 10, again I will go ahead and I will check this value of j. So j is currently here, j is at 2. So 2 is less than, what is the value of k? K is actually size, or here I should actually in the pseudocode, this will not be k, rather I should say I should write size of the actual array. This is the size of the actual array. I should write it size. Guys, kindly check it. This is the type of simple typing mistake. This will be the size of the actual array. So this is what n or something like that. You can represent it with n or something like that. So when you can again check 2 is less than the size of the actual array, this condition is also true. So again I will go here, I will go inside it, and I will increment the value. I will increment the value of sum. Right there you can see, after we got the desired size window, the window size is 3. There this condition will be false, because we have also incremented this size. After each step I am incrementing the value of j. After each step I am incrementing the value of j. So when we got this desired size, after getting the desired size, I will simply go ahead here, because you can see when the window size will also be 3 and the actual size of the window will also be 3, I will not again go inside this condition. Rather I will go in the else if condition, that whether this window size is same or not, and the window size will be 3, because at this particular step when I have incremented the value of j, the window size is also 3 and the given size is also 3. When both the things are equal, I should check what is the maximum of them. Now mx variable is containing the value int mean, and sum is containing the value 10, because here 3 plus 2 plus 5, this is 10. This is the value, this is 10. So among 10 and minus infinity, obviously 10 is greater, so I will update the value of mx as 10. So mx is holding the global maximum, mx value will have the value of 10. So now this is our global maximum value, current sum, for this particular window, this is the sum. Now to slide the window, what I will do, I will simply increment the value of I and decrement the value of j. So now the window will come right here. Now the window will come right here. Now when I have when our window is right there, before that we also have to remember one thing, that I have to exclude this part and I have to include this sum, because definitely I'm including this sum beforehand. Whenever I'm inserting in this while loop, you can see I am inserting in this while loop, I will be incrementing it. I will be incrementing the value of 9, but I should decrement this value right here. So that's why I am decrementing the value of I before incrementing it. So I am removing the value 3 from this sum. So the current sum is 3. I am decrementing the value 10 minus 3. So what is the current sum? 10 minus 3 is 7. So 7 is the current sum, and whenever I will enter in this loop again, I will increment the next value. The next value was 9, so I will add 9 to it. In this way I will go on, I will go on. In this way I will move on. So I guess this is the dry run. If you are watching the sliding window concept for the first time, it will be a little bit confusing, but I guess now you guys are able to understand. You guys can give your feedback that whether you are able to understand this question or not. I am going to ask that whether you guys are getting it or not, or do you want me to explain it once again? Just let me know once that whether you guys are getting it or not. Yes, sir. So just take like whether they are understanding or not. Just take a quick feedback. Guys, please take the dry run once again, and if you want to take the actual problem, right here it's the problem, and for this one this is a bit simple typo. Like when like the PPT was getting prepared, the size is K, right here K is size, so we have to write the size of the array, and this K is the size of the window. This is a simple thing. I have while discussing I told you all. So this is a sliding window question, maximum subarray sum of size K. This is one of the most famous interview question from sliding window. And if you guys want to understand it again, or if you guys have any question, you can directly contact me. If you guys have any question, any doubt regarding this problem, you can contact me. Otherwise, you can actually understand this part. You can try to implement it yourself. Take a look at this slide, guys. All right. So I think you have understood the sliding window question. So I'm moving to the next concept, the next part of our agenda, and it is nothing but the most awaited dynamic programming. Dynamic programming, a lot of people they actually fear right here that what is dynamic programming, how to write dynamic programming. But believe me, guys, if you have a little bit focus and if you have a little amount of like the visualization, you can understand dynamic programming and you can write any dynamic programming code, and I'm guaranteeing you that you can write actually any dynamic programming code. All the things will be super easy. Now I'm going to give you a very famous interview question from the last year, like in the last year, Microsoft, and also not only Microsoft, Zscaler. Zscaler is a company. You have heard about the networking company. I don't know how many of you know about Zscaler. It is also a very good company, and I guess all of you know about Microsoft. In Microsoft interview also, a variation of the question that I'm going to discuss, a variation of the question was asked, and that question was LCS question. This question was there, longest common subsequence. And this kind of questions are like the parent question, whatever I will discuss, because in programming world, you know that there are millions of questions. There can be infinite number of questions. This is the bad news for programmer. Like there can be millions and millions of questions. But what is the good news then? The good news is all the questions are like they are of a particular category. They have a parent question. Like if you want to go somewhere and if you want to know the culture of a particular community, you cannot cannot go to each and every people in this entire world and you can ask. There are billions of people, and you cannot go to each and every place and you cannot have the idea of their culture. That's why this entire world was categorized into continents. There are continents like Asia, Europe, there are America, there are continents like that. And if you want to go to any continent, and you will be having the idea of that entire continent. Now, if you want to dive deep into that culture, you can actually go to India, you can go to some America, you can go to Sri Lanka, Bangladesh, you can go to any specific country, and then you can understand the entire culture of the Indians, of the Sri Lanka, or you are going to Bangladesh, you are going to Pakistan, you are going to anywhere, you will be able to understand the culture of that entire country. So these are just like that. This parent questions are like that. If you understand one single parent question, you will be able to understand all the similar questions and you will be able to code them yourself. So without wasting any time, at first I will discuss the question, and then I will go about why recursion and why dynamic programming. So the question is something like that. There will be two strings given, string 1 and string 2. And you have to return the longest common subsequence. Here you can see the longest common subsequence. I'm underlining it. I'm just giving you this part. Just a minute. Yeah. So here I have. the longest common subsequence. Now, what is a subsequence and what is a substring? What is the difference between them? So, substring is basically it should be continuous. You can see the difference between subsequence and substring is given. It is continuous. The substring, it must be continuous. That means if this particular string is given to us, what is a substring? The substring can be A, B, C, D. This is a substring, and this is also a subsequence. This is also a subsequence because subsequence can be continuous or non-continuous. Both the things can be there. It can be continuous or non-continuous also. So I have highlighted some. I have highlighted the subsequence of this particular string and this particular string. So A B D H, A B D H. This is a subsequence which is present on our string 1 and string 2, A, B, D, H. In both the string, this particular subsequence is present, and subsequence, it can be continuous, it cannot be continuous, it doesn't matter. And why ABDH is the subsequence? Because it is the longest common subsequence. It is the longest, it is common, it is present in both the string, and it is a subsequence. So that is the meaning of LCS problem. This LCS is a super important problem, because after learning LCS you will be able to solve more than 20 plus dynamic programming problem of the same category. More than 20. So definitely I can guarantee you can actually solve more than 20 problems. They are of same the LCS pattern. They follow the LCS pattern. And in this question, you do not have to print this ABDH, rather you just have to print the length of the substring. So you do not have to print the longest common subsequence, you have to print the length. You have to print the length. This is what you have to do. Now suppose I have this A, B, C, D, G, H and this. Both the things are there. How will you able to understand and how will you calculate that? What can be your approach? So the first approach is the naive approach. What can be the naive or what can be the brute force approach? So in this approach, what you will do? You will generate all the subsequence, right? All subsequence of this particular string. So if I have A, B, C, D, G, H, definitely A, B, G, this can also be a subsequence. I can have A, C, H, this can also be a subsequence. I can have A and G, this can also be a subsequence. So there can be multiple subsequence. Now you have to find, this is step number 1. Step number 2 is you have to find all the common subsequence. All the common subsequence, like AB is a subsequence which is present in our string 1 and AB is also present in our string 2. Also there can be another common subsequence like A, B and D. This is also a subsequence which is present right here and right here in both the strings. There can be only A, H. This can also be a subsequence which is present right here. You can see A and H. This is also a common subsequence which is present in both the string. So among all the common subsequence, you have to find the step number 3. You have to find the longest. That is whose length is maximum. This is what you have to do. So these are the steps. Now definitely this can be done in the naive approach or brute force approach. But is there any optimization technique? Is there anything that we can do? And the answer is yes. So how we can do and what we can do, let us try to understand with the help of a diagram. So here I have a specific diagram right here. This is our string 1. This is our string str. Just a minute. This is our string 1, str1, and this is our str2. This is our initial string 1 and string 2. So what we do in this recursive, and remember this is what we are doing as recursion. This is what we are doing recursion, because dynamic programming DP is 100%, almost we can say the memoization technique is 100% recursion plus space. This is nothing but dynamic programming. You have to write the recursive solution and you can add some space, or we call it cache. We call it the cache memory. You just have to add some cache. Recursion plus cache is nothing but dynamic programming. So whenever you are able to formulate the recursive formula or the recursive code, you can just add some cache. This can be a simple array, this can be a simple string, this can be simple storage where you can like variable kind of storage, and that will become a dynamic programming solution. The time complexity will reduce drastically. So these are our string. So what we do in this approach is we actually take the last character, and we take the last character of the first string and the last character of the second string. Guys, please listen carefully, and this is the last example that I'm discussing. Please listen and like focus right here. Focus is the only issue that like this for this reason only students are not able to perform well. So please focus. I can see like your video is on, so I can see everyone, and I have two monitors open also, so that's why I'm continuously seeing you all. So please kindly focus, guys. So what I will do here is I will take the last character of the first string, and I will take the last character of the second string. Now these are two independent characters. Think about it, just try to visualize it, guys, that we have two characters. Now if I have two different numbers, or if I have two different characters, what can be their relation? Either they can be same, or they can be different. I have two characters, so either they can be same or they can be different. The characters can be anything like D and H. This can be the characters. So either or the character can be, let's say, B and K, or the characters can be A and A. So anything like that, in this way, any character, any combination can be there, or their relation will be either they will be different or they will be same. They will be either different or they will be same. These are the only relationship that can be there between this blue and this red. Blue is representing the last character of the first string, and red is representing the last character of the second string. So this can only be the thing. So now in our longest common subsequence problem, we have to find a subsequence, and it should also be common. So common means they must be same, the same characters. We are interested only in the same characters. So if they are matched, so I can actually leave this particular part, I can leave this, and I can take the remaining part of the string. This is the remaining part of the first string, and this is the remaining part of the second string, and from there I can again call the same function, right? And I will add 1 to it, because one character already matched. This character and this character, they have matched. So if they had matched, so definitely the subsequence which is common, their length will be minimum 1, because they have matched. Are you able to visualize it? Guys, please don't look back. Please don't look back, and please don't try to understand here, try to focus here. If they have matched, so obviously length will be incremented by 1, and when the length is incremented by 1, after that I have this same string, same kind of two different string. So here also again I will take the last character of this string, and I will take the last character of this string. I will take this two, and again I will do the same kind of recursion. Like I will check whether this is matching with this or not. If they are matching, then I will take the remaining part. In this way, after going on and on, at some time I will be having either one string, any one string will be empty. Like in this way, I have one character left and another string is empty. So when another string is empty, I cannot have any common thing, because one string is there is some character, and in another string we do not have any character. So LCS definitely will be 0. So in this situation, I will be returning something. So this is a simple example like how the recursion is working. Recursion means following the same thing again and again. Recursive call I will make from here. Recursive means when the same thing, we are repeating the same thing again and again. This is what we mean by recursion. This is what also we are doing here. Now let's analyze the second option, that when they are not matching. When they are not matching, then what we should do? So when they are not matching, we have two different conditions. Like I have to take the longest common subsequence, right? I have to take the longest common subsequence. So right here I will take the remaining part of the first string. So if the length of the first string is n, and I am removing one character, so what will be the remaining length? The remaining length will be n minus 1. So I will take the n minus 1. Here also I have done the same calculation. N minus 1 is basically the remaining part. Here, if the length of the second string, entire second string is m, what will the remaining length? Remaining length will be m minus 1. These are the remaining parts. So there, at one time, I will take the entire second string and the remaining part of the first string, or I will take the entire first string and the remaining part of the second string. I will call the recursion. I will have the same recursive call. Now with this one and this one, I will again take the last characters. I will do the same matching. Either they will match or they will not match. So in this way, I will hit the base condition where one string or both string, anything will be empty, and there I will return 0, because at that time I cannot have any longest common subsequence. So among them, which one will give me the maximum, I will consider that maximum and I will return to the parent. This is what we are doing. Now why we are doing it, let's try to analyze with the help of one example, and this is the same example that I have. So let's say I have this string. So according to our algorithm, what I will do, I will take this particular character, because this is the last character of the first string. H is the last character of the first string, and I will take the last character of the second string, that is R. So are they same or are they different? So they are different. So since they are different, I will go to the second path, because this path was for when they were same. So in this path, I will consider two different strings. So I will consider A, B, C, D, G and H, the entire first string. You can see entire first string and the remaining part of the second string, because I will not consider the R now. So it will be A, B, E, D, F and H. I will consider these two strings and I will have the same recursion, or else I can have two more combination like A, B, C, D, G, and I will not consider the last string and I will take the entire second string. The entire second string is A, B, E, D, F, H and R. So this one and this one. Now again we have two independent problems. This is our string 1, this is our string 2, or this is our string 1, this is our string 2. So now from this one, can we get the longest common subsequence for this two string? And if we can get the longest common subsequence for this two string, we can return that to get our original solution. Or we can also get the longest common subsequence, or LCS, the length of LCS for this two string, and among them which one will give us the maximum, I will return that to our parent. Now let's say we are trying to analyze the first path, we are trying to analyze for this one. So H and H, when they are matching, so I will remove both the H, because once they have matched, I will only count them only once. So I will add 1 to it and then I will have the same recursive call. So this is what we are going to do. If you are wondering how we can write the code, so let me show you the pseudo code kind of thing, where I have written the pseudo code right here. In the same example, you can see I have the first string S1 or X, the second string as Y, the length of the first string is N and the length of the second string is M. So if any one of the string is N equals to 0 or N equals to 0, M or N, anything is 0, that means the length of the first string or the second string, anything is 0, that means they are empty. So if they are empty, I will simply return 0, as I have already talked in the base condition. You can see the base condition is if they are empty. So how to represent in program or in our code that any of the string is empty? Their length must be empty. So N equals to 0, the length of the first string is 0, or this is the pipeline symbol, or M equals to 0. So I will return 0. That no LCS is possible, because there can be something to match. Now the second thing, I will take the last character. So if the string behaves like character array, so I can write X and inside the square brackets, just like array indexing, like we write the index here,
I can write n minus 1. So if n is the length of the first string, so n minus 1 will represent the last character. Do you know that? I guess you all know that this will represent, this is the index of last character, index of last character of the first string, definitely of the first string, and this is the index of the second. So definitely we are doing in this way. So if this is the case, I will add 1 because they are matching. So if they are matching, I will add 1, and I will have the same function for the remaining parts, for the remaining part of the same string we have passed, and we are doing it for the remaining part. And else I am actually trying to get the maximum of the entire first string and the remaining part of the second string, and the entire second string and the remaining part of the first string, as we have explained in the example. This is the entire recursive solution. And if you try to memorize the solution, these are the three lines, three highlighted lines, some few more thing I have written. You can see this is the cache, this is the array I have written, and this is the memoized version, and this is your dynamic programming code. This is the entire dynamic programming code. If you are wondering that how we have written this, there are no such extraordinary thing. I have some cache or I have some memory. In the main function, I have initialized all the cell with -1, and I am checking before, like before storing something or before returning, I'm checking the value of any particular cell, and I'm storing the value in that particular cell. This is only this dynamic program. So if you are wondering, do not wonder, do not get worried that what I have written exactly here, this 3 or 4 lines are common in all dynamic programming code. If you are able to write the recursive version, you just have to write this 2 to 3 lines of code, and the recursive code will get converted into dynamic programming code. The same code, 100%. You can see I'm doing the same condition checking, and before just this part, the recursive case, I am just checking this condition, like whether this is present or not. Present or not, for that purpose I have this -1, because I have initialized the matrix with -1, all the cell. So -1 represents that the cell, there is no value, so we have to calculate the value. So yeah, this is it. This is the basic LCS solution. And in our actual program, we will in our actual course, we will definitely dive deep into all the dynamic programming codes, right? Yeah, so this is it, guys. If you have any confusion, if you have any queries, if you have anything to ask, that whether this will be covered or anything extra about the roadmap, or there is anything like any kind of query, or you want to explain some code once again, you can directly contact me. Like I will personally help you to understand any particular code or any particular query that you are having for any doubt clearing. uh, okay, so guys, thank you so much, guys. I hope you all liked the workshop. You have at least gained that, you have gained the roadmap, that what you should do, how you should do. So if you have any queries, guys, please let me know, guys. Students, all the students, best of luck for your future. Do learn DSA. This is the most important thing. Any query, just like get back to me once. Thank you so much, guys. All the best.